Alright guys, welcome. This is week 4. The lab is product labels. So a couple of things I need to make note of here on the agenda. First, we want to recap everything I covered in week 3, which is all the regulatory stuff. We won't really talk about the supplier approval program, so it's not really relevant to this particular lesson. After that recap, we'll talk about the lecture itself, the product labels. I'll show you guys various things like how to read certain components of the label, as well as doing some nutrition calculations. Then I'll give you your assignment, which is basically doing those nutrition calculations as homework. There will be a little bit of math review, but I'm coming into this expecting you guys to know basic math like proportions, equations, multiplication, addition, stuff like that. But of course, people may make mistakes, so I'll go over the different problems. Alright, so last week we discussed in great detail the roles of federal and state, as well as local agencies, in protecting the interests of all the entities it represents. An entity can be any sort of person, place, or thing. And in the case of the food industry, what sort of entity is protected specifically depends on the function of that particular branch of that regulatory agency. So, for instance, any legal and regulatory requirements that are enforced by federal agencies with the purpose of food safety, the purpose of that is to protect you and me. And so the entity is the consumer. Some federal regulations with regards to the quality of a food define its standard of identity. So, for instance, I brought the example with champagne that has to come from a certain region of France. Or perhaps there may be strict standards against adulteration for the purpose of economic gain. So, like, for example, cutting olive oil with cheap vegetable oil to cut costs. Then, in that case, the entities that the agencies represent are the wine and olive oil industries, respectively. And the food industry is heavily regulated, so if you were to work in quality or really any food scientist position, you may be interacting with government agents frequently at all levels of government, from city to state to federal. So it's important to be able to learn what they do, what they function, the different laws that you may need to follow, so on and so forth. The other thing I want to refresh you guys on is the fact that the FDA regulates the labeling of most foods. This includes products which contain meat. This is in large part because the FDA is responsible for controlling the food supply with respect to adulteration and misbranding. They want to make sure that the information that is available to the consumer upon encountering the product and reading the packaging is transparent, honest, and helps consumers determine whether or not the product is good for them, both in terms of their health and their money. This will be several different aspects of the label, from the front to the back to the nutrition label. Now, with regards to the nutrition label, the following commodities are not subject to this regulation: raw agricultural products, such as rice, unprocessed fruits and vegetables, big bags of beans. Those are not subject to the regulation. Any sort of hard liquor that's above 6% is not regulated by the FDA at all. Even below 6%, any sort of labeling is optional, at least with regards to nutrition labeling. And the majority of the other matters within alcohol below 6% are regulated by the TTB instead. So yeah, just remember those things going forward. Let's talk about the actual labels. Now, there are a couple of laws that I want you guys to remember for this course, which are specifically enforced in the food industry by the FDA. The first is the Fair Labeling and Packaging Act, or the FLPA. Now, technically speaking, the FDA isn't the one that enforces this. It's actually the Federal Trade Commission, or FTC. The FTC sets packaging guidelines for all kinds of products, but the FDA gets involved because it's within its jurisdiction. Anyway, what exactly does this law do? Well, it sets the mandates that consumer products, such as the prepackaged food that you and I buy, these must provide sufficient information for consumers to make value comparisons between products and understand where the products originated, while ensuring that there are fair business practices in honest marketing and packaging. So obviously we will talk about it in detail, but long story short, there needs to be no false claims on there. If there are any nutritional claims, they need to be backed by the science and meet the standards that the FDA sets. Companies cannot exaggerate how much food is in their packaged product, so you can't have anything underweight. And consumers need to be able to trace the product back to the manufacturer, or at least the distributor, so that they can make complaints. The other big law is the Nutrition Labeling and Education Act, or the NLEA. In effect, this law requires nutrition labeling for any products which are not included in the exceptions list I gave earlier. For example, nutrition labels are not required on big bags of rice per se, but if that rice was used to make a pre-made fried rice product, that fried rice product will need a nutrition label. Soft drinks require nutrition labels. Cereals require nutrition labels. Canned soups, prepackaged ramen, pre-made meals that you see at the grocery store. At least for the ones that you don't see made in house, anyway. Which even then, regulations are pushing more and more to having those having at least the calories listed. If you ever were to go to a hot bar at a grocery store, or like one of those counters where they are serving some sort of pre-made meal, a lot of those will now have calories displayed, whereas they would not have before. And part of that's because of this act. Items on vending machines now need to display the calories somehow. Either for a glass display case using the food itself, or if it's one of those drink machines where it's hidden behind plastic, you have to have some sort of label that shows the calories on it. The NLEA is going to be the bulk of the second half of this lecture, so sit tight for that. There's going to be a lot. Now, when you look for an item in a grocery store, what is the first thing you see on the aisle? It's the front of the product, right? Usually. Unless someone was clumsy or careless and they put it in a weird position. But, regardless, most of the time you'll see the front of the product, right? Well, there's a name for that. That's the Principal Display Panel, or the PDP. If you want the more formal definition, it is the part of the food label that is most likely to be displayed to the customer when it is presented for sale. There are a lot of things that you can put on a Principal Display Panel, but there are two things that you absolutely must have by law. The first is a statement of identity, what it is. And this is usually just the name of the product. For a lot of products, especially generic ones, usually the name as it would be recognized in the regulations is enough. If the majority of the general public calls a food by a certain name, that would be enough too, for some things like milk. That's often called a common name. However, for some other products, it could get more complicated than that, especially if there is a standard of identity. In which case, you have to make sure that if you want to name it a certain thing that is regulated by law, you need to make sure that your food meets the requirements to have it qualify under the law, to be labeled as such. Now, there are some products out there with names that don't actually match how they're described physically. Like, for example, have you ever had buffalo wings? That's not literally a buffalo's wings, right? That's chicken wings with buffalo hot sauce on them. In Pennsylvania, there's a dessert called shoe fly pie. Now, despite the name, there are no flies in there whatsoever. It's basically a pie with molasses in it. And it's very likely you've had a bunch of different foods in your life that are unique to certain regions, unique to certain restaurants or whatever. They're a variation of some kind of dish, and they have their own names for it. That's basically what it is. That's called a fanciful name. And how the FDA treats it, well, you're allowed to put those fanciful names on labels, but you must have a more common descriptor along with it. Or at the very least, something that the FDA would recognize on a technical level. Like, let's say you had some cereal named like Sugar Bombs or something like that. Basically, how your company makes it is they make a bunch of like puffed corn treats, and they stuff a bunch of sugar in it. They pack it with sugar. They even sugar frost it. They sugar dust it. But in the end, it's still like a puffed corn cereal that you put in a bowl with milk in it. Well, you also have to list it on the front somehow by its more common name. Or I guess in a case of a combination dish, like something that combines several different things together, like a more accurate descriptor, as they would call it. So most consumers will recognize your cereal as a cereal, and you'll have to list it as such. You can't leave it out of the box. So while your label might have this huge logo with it saying like Sugar Bombs or whatever on the front box, you must also have somewhere on that label, visibly, the font needs to be big enough to see with the naked eye from far away, like artificially sweetened puff corn cereal or something like that. Actually, what am I doing? I can give you a realistic example. There is actually a cereal out there called Cookie Crisp. And yeah, here it is. This is a box of Cookie Crisp I pulled from the Vaughn's shopping website, just to give you guys an example. The Cookie Crisp in this case can technically be considered a fanciful name. However, because it is a cereal, you'll probably notice in the bottom left corner, let me just blow it up a little bit. You'll notice that it's labeled as such. And of course, it is a sweetened cereal. After all, it does contain chocolate. And of course, in addition to chocolate, it contains plenty of sugar, as well as some natural flavors and colors. Therefore, while General Mills can call this Cookie Crisp, it must label this product also as a naturally flavored sweetened cereal. That is the descriptive term for it. General Mills, the manufacturer of this product, must have naturally flavored sweetened cereal on the box. If it's missing, it could be considered misbranding. Because per the Fair Labeling and Packaging Act, no matter what sort of name it has for this product, it must tell consumers that it is a cereal. Since I mentioned it as an example, here's a buffalo wings, just to give you guys another visual. Let me go ahead and zoom in on this one. So the fanciful name in this case is the Takeout Crispy Wings with classic buffalo sauce included. But as you can see here, the technical name for it, or I guess the descriptive term, is chicken wing sections with a buffalo style sauce. If your product can come in different forms, you have to specify the type of form it is as well. So in this case, they make it clear that it's the chicken wing sections. So you take that whole wing and break it to the individual chunks. The whole wing is pretty large, but you can usually break it into 3 different sections. You have the part that kind of looks like a drumstick. You have a flat part, and then you have a little like tail end that you kind of throw away. I guess some people save that for soup or something, but either way, that's what's happening here. So they specify it's the wing sections. So you're not getting the whole wing, you're getting the wing cut up into those 3 separate components. And that's why you often see these sort of descriptors on labels, even though there is a name for it already, like the name that they display more prominently. Basically, the consumer should look at that part of the label and know exactly what they're getting once they open that bag. So when I open this bag of wings, I know I'm not getting the whole wings, I'm just getting those sections. And there should be a plastic cup with that sauce somewhere in there. Or maybe a packet. Alright, so skipping forward a slide, because this is basically the entire summary of that second bullet point on that slide. The second thing that a principal display panel needs, or PDP, is the net contents statement. Okay, so the net contents are a very important part of the food industry. In addition to quality, weight is a matter of logistics, it's a matter of sales, purchasing, engineering, and it's very much an important specification for our products. The net contents, this is either expressed or weight and volume, most often weight. It's the amount of the product inside a package in terms of its weight or volume. As far as the weight goes, if you add the weight of the package, you get the gross weight. As per the regulation, the net contents, or the net weight in this case, needs to be displayed on the principal display panel, and it must be in US measurements. Most commonly in ounces, or pounds if it's large enough of a product. And then the metric unit conversion is usually listed in parentheses next to it. I have seen it where it's the reverse before, but that's not very common. And usually I recommend that all companies list it the way I mentioned earlier, with the US measurements on the left and then the metric on the right. If you ever look at a can of soda or maybe a carton of beverage or something like that, you can see that as well. So let's say you bought a can of Pepsi at a gas station. Let's say that can of Pepsi was 12 fluid ounces. Will be listed as 12 fluid ounces parentheses 355 mils as it's displayed here. Now, why is this regulation so important? Well, there is a number of reasons. So first, the net contents as a specification is mandatory due to the Fair Labeling and Packaging Act, or the FLPA. The net content on a package could communicate to the customer exactly how much that customer is getting when they purchase the product. If you ever go to a retail or distribution location and you notice a sign out front that states that the state's Agricultural Department's Division of Weights and Measures has inspected the place, well, this is the reason. They always test the scales over there to make sure that they're calibrated properly. They want to make sure that whatever weights are measured at that establishment, and a lot of operations have to do so by law before they ship or deliver anything. They want to make sure that those statements are accurate and that consumers are actually getting exactly the amount of product that they pay for, and they're not being cheated. In fact, it is the job of the state inspectors to come in, test the weights of random products, and then if they find anything under the stated weight, they have to pull those products from the shelves. And this is by no means limited to just stores and distributors. It goes for manufacturers too. By making sure that all businesses comply with this regulation and making sure that they're honest about the net contents of the statement, it prevents companies from cheating by filling their packages with less than the stated amount. It may not seem like much to be under a gram or under an ounce or so, But that adds up over thousands and thousands of packages, and the company could theoretically save a lot of money that way. That just isn't a fair or honest business practice. And that is why you must state the net contents on your package of what a product you are selling. On the back or the side of any panel of a package, there must be some business contact information. The business that must be listed must be the business that's responsible for selling the product. The name of the company has to be current. The address has to be current. The phone number, the email address, or the website, if any, those have to be current. And on top of being current, those things have to point to the main headquarters or the main office that is responsible for handling any sort of regulatory or customer complaints. Most often, this is the manufacturer. However, for larger brands, it is very common for larger brands to contract out to other factories. In fact, distributors often do this, even the small ones. That's usually the case with anything that's private label. Now, in those cases where the company selling it isn't the same company producing it, that's actually valid, and it's okay for those companies not to disclose who produced it for them. What they do instead is list their own address and contact information on the label, and then they would say distributed by, or sold by, or produced on behalf of, and then the name of their company and their address. The next time you go to a big chain supermarket like Trader Joe's or Costco or Whole Foods or anything like that, check some of the products that are listed under their store brand and check the back of the label. Chances are it'll say produced on behalf of or produced for or sold by or etc. etc. And then it'll have that retail chain's contact information on it, not the manufacturer's. You know that little barcode you see on some of your products? Well, there is actual meaning to that barcode. This is called a UPC code, or Universal Product Code. It's a really important way to track items, especially for distribution and retail sale. I'm oversimplifying it quite a bit, but basically how it works is you have this 12-digit code down here. And these digits can range anywhere from 0 to 9, and they can repeat. Each of those numbers generates a bar pattern that you see above it, and that 12-digit combo and the bar pattern identify the product. A UPC is unique to every type of product, even down to the sizes. So if you were to have two of the same product in two different container sizes, they will have two different UPC numbers. And for each product, that's 5 different digits, and that's where the product code of this part comes from. So that's the 5 digits on the right side. In this case, the 6, 7, 8, 9, and 0. Now you can also tell who produced it with the 5 digits to the left. So in this case, the 1, 2, 3, 4, 5. A manufacturer actually has to apply for a UPC code before they can get one. And that UPC number is assigned to them permanently. Now I have to admit, I didn't pick the best example here for this picture, because it requires me to go into more depth than I wanted. But the digit on the left, there are different types of UPC codes. The digit on the left could be another number that's added to the ID of the manufacturer. But in other UPC formats, it could actually correspond to the type of product it is. So like for example, for products that vary a lot in weight, like meat, it will have a first digit of 2. For some coupons, it'll have a UPC code of 5 or 9. Non-food items that you see in retail would be marked with a 4. Drugs and pharmaceuticals are 3, so on and so forth. Anyway, that's not important. What is important is understanding that the left identifies the manufacturer and maybe the type of product it is. And 5 of the digits on the right indicate the product ID itself. Now, you can buy a UPC scanner just about anywhere. They're used in a lot of businesses. You can probably find one on Amazon. In fact, I did find a couple on Amazon, and they range anywhere from $20 to $40. Well, you can use those scanners to actually scan the item that has that barcode on there, and it'll identify everything for you about it, from who created it, some of the dimensions of the product, some of the specifications, whatever's been entered. Of course, that information is only as good as the manufacturer and the software that created it. Speaking of which, the UPC code can be buggy sometimes. That'll either happen because, well, maybe the scanner's not reliable all the time, or actually more commonly because of some sort of data entry error. A lot of data is input manually into the UPC system. The last digit on the right is designed to pick up on those errors, and rather than give you a fake result or maybe a bad result, it'll just say it failed to detect. That is what it's for. Country of origin. So I could have talked about this when talking about product specifications, because that often counts, but it really matters here most of all. Now, speaking of which, I made a sort of mistake here. The Farm Security and Rural Investment Act does enforce country of origin rules, but only for certain meats, such as lamb, pork, and beef. That was enforced by the USDA at one point, but in 2014 that was struck down. But listing the country of origin is still required, this time enforced by the Customs and Border Patrol, or CBP, not the FDA or USDA. And it applies to all products, not just meat. The country of origin indicates where the product is from. I do recall seeing it listed on different sides of a box or packaging, but the most common place for it is in the back of the label. Note that I said product. A lot of foods contain ingredient sourced from different countries, but the only country that must be listed is the country where the final product was made. So if you source cocoa from Africa, you source milk from Europe, and you source wheat from, let's say, Canada, well, you manufacture the cookies here in the U.S., then you have to say product of USA. Also this week, when talking about supplier approval programs, I mentioned repacking or co-packing businesses. You can even use the country that the repacker is from. If any of you saw that Truffles documentary last week in the recommended videos, well, you will see an example of that. The country of origin is important to ask when you're handling supplier approval programs as well. And businesses can handle this in a number of different ways. One, they can just state the country of origin that's listed on the product itself. Two, the country of origin can be listed on the spec sheet. And three, they can actually issue letters to specific customers asking about it. And they'll have a complete breakdown of the different ingredients, where exactly those things came from that contributed to the final making of the product. Alright, so on a food label, the ingredients must be stated somewhere on the packaging. It can be on the principal display panel, but that tends to be kind of rare. It's usually on the back, or in some cases on the side. Either way, you have to have exactly what's in the product listed somewhere. This is called an ingredient statement. You could also just call this an ingredients list. You have to list every single ingredient that went into the final product. This is always in order in terms of weight. The first ingredient must be the one that is in highest abundance in the product itself. For instance, for most beverages, it should be water. For most meat products, like say some sort of seasoned steak, well, the main ingredient should be beef. Excuse me, the first ingredient for a seasoned steak should be beef. Many ingredients themselves contain lots of ingredients on their own, and so those components have to be listed as well. Soy sauce is a very common example. So most of you probably know that soy sauce is made from, as the name implies, soybeans. Well, those beans are soaked in water for a while, and then a yeast starter called koji is added. The traditional way of doing it, and indeed the most common way to this day, is to combine soybean mash into a paste along with roasted grains. So wheat is actually used in soy sauce making. That yeast then ferments the soybeans and wheat together, and then eventually that's transferred to a tub where it's soaked in a brine with a lot of salt in it. And that's where the actual aging, the breaking down actually happens. Speaking of which, fun fact actually, a lot of umami byproducts may result from the fermentation process and the aging of the soy sauce, but another product that comes out is alcohol. So naturally brewed soy sauce contains a small amount of alcohol, like ethanol, and some is actually added on top to act as a preservative. This right here is Yamasa brand soy sauce. Let's check the back of the bottle here, and you'll see that alcohol has been added. And that's pretty much the traditional process and the so-called natural brewing of soy sauce. My point being, if you add naturally brewed soy sauce to your product, you have to list all the components. So in this case, water, wheat, soybeans, salt, alcohol, vinegar, and lactic acid. Now, if you were to add this soy sauce as an ingredient to another food, here's how it will look. If you're just listening into this lecture without looking at the slides, now would be a good time to pause. Alright, moving on. So the last comment I want to make before moving to the allergens component is that not every ingredient that goes into the manufacturing process has to end up on the ingredients list. Did you notice how I mentioned that only the ingredients that end up in the final product have to be added onto the final label? Well, sometimes certain components are removed from foods during manufacturing. The best example of this would be refined sugar, the white stuff. Sugar starts off as a nasty looking sludge from sugarcane, but every step of the refining process removes something from the sugar. To move from brown sugar to white sugar, to simplify it, basically you're removing a lot of molasses. So when you look at a bag of white sugar in the ingredients list, you'll rarely see molasses on there. It'll just be white cane sugar. All the components that have been removed from that sugar are rarely, if ever, labeled on white sugar. Alright, enough of that. Let's talk about allergens. Here are the list of the big 9 allergens. It used to be big 8. Most of you probably learned it that way. The big 9, the ninth one there, sesame, is kind of a new addition that has been added as of this year. Actually, April 23 of this year, the Food Safety Treatment, Education, and Research, or FASTER Act, has been signed into law. And basically, this one requires the addition of declaration of sesame as an allergen in your foods. Actual enforcement of this will not happen until 2023, so companies have time to comply. But that's something that I want you guys to look out for. Now, in case you're wondering why sesame is being added as an allergen, well, it's actually been a declared allergen requirement in other countries like Canada for years now. The industry here in the U.S. didn't really see it as a major allergen, and they often hid it in like the listing for like natural flavors. Sometimes it's hidden among the various spices that are listed. But there has been enough research in recent years to warrant it being listed here in the United States after all. But aside from sesame, the new one, there are 8 others: milk, eggs, wheat, soy, fish, shellfish, and by shellfish I mean mostly crustaceans and arthropods like shrimp, crabs, stuff like that, crayfish. Not things like snails, scallops, or octopus. Just the ones with the hard shells and the like segmented, jointed bodies. Lobsters would count. Squid would not. Peanuts and tree nuts. By tree nuts, they usually mean things like walnuts, pecans, hazelnuts, um, cashews, which actually come from a fruit, but they're still classified as nuts due to the mechanism of allergy, and almonds. I believe coconut is lumped in with tree nuts as well. Now, the allergens in the product have to be listed on the ingredient side of the panel, and it can be done in one of 2 ways. So I pulled this picture of clam chowder from the internet, the back label, and it's showing one of the methods. Basically, you list all the allergens at the bottom, grouped together. You put them in big text, bold font, with all capital letters like warning or allergy warning or contains, and then you list allergens that are relevant. Now, because of the cream, the butter, and the whey, milk has to be listed, which they did. There's a little bit of soy protein concentrate in there, so they listed soy. Now, interestingly, soybean oil actually does not require the listing of soy as an allergen in most cases, if it is a refined soybean oil. Refined soybean oil does not contain the protein that causes the soy allergy. It's always removed as part of the process, and it's part of soybean oil companies' HACCP plans. Anyway, moving on. Looks like they're pretty good about the shellfish. So there's a little bit of lobster powder in there, crab powder, and shrimp. So it's good that they listed those allergens on there. And then, of course, all the different fish that they use, they have to list that as well. And that's all there. Now, it doesn't have to be this exact method. You could group the different allergens together. Like you could do like milk, parentheses, butter, um, cream, and whey protein. You could group all the fish together, like fish, parentheses, all the species. And you actually have to do that, or list it the way they did. Same with the shellfish. You have to list them together and specify the species. That's sort of unique to shellfish and fish, though. For anything else, let's say they use different forms of wheat, like maybe they used a little bit of flour, then they added a little bit of crumbled biscuits in there, or they added some sort of whole grain pasta in there. You could just list wheat, and they kind of did that for the milk, as you can see. But anyway, that's the first method. Let's look at the second. Now, I don't know the exact identity of this product, like the brand or the product itself, but judging from the ingredients list, it's some sort of cake mix. But this is the second method that you can use. You can pretty much just embed the name of the allergy in the ingredients list itself, like this. If the ingredient just is eggs, it just is milk, it just is soybeans, you can just list it as such, as plain as day, in plain words on the ingredients list. It'll be implied that it's an allergen. For those which are not immediately obvious, like soy lecithin, you have to put in parentheses what that allergen is afterwards. So, actually, they're all examples here, so the ones that are highlighted. The enriched flour is basically just wheat flour with some malted barley and some vitamins added in. So, wheat flour is the first thing that's listed in the parentheses there, and that covers the wheat allergy requirement. For the whey protein, they just said in parentheses milk. And for the lecithin, well, the soy is the allergen, so that's in parentheses too. So that's the second method. And to be honest, actually, it's not uncommon for me to see companies use both methods at the same time, combine them both to make sure they get maximum coverage of allergens. You know, having a recall due to allergens is pretty embarrassing, and it can be pretty costly. So they definitely don't want that on their hands. So if you were to go grocery shopping sometime, you might actually see products with both methods used, but either one or the other is required, at the very least. Sometimes companies make multiple things on same production lines, and they share equipment, and that can cause allergens to cross from one particular product to another that's not supposed to contain it. So a lot of companies will often put an additional allergy caution statement called like, caution may contain peanuts, may contain this other allergen, or caution processed on the same equipment for products that contain this allergen. That's not really required, and it doesn't really offer the same sort of legal protection that adding allergens in the ingredients list does. But it's something that food companies do a lot to try and reduce their liability somewhat. So it's usually a smart course of action to include that anyway. All right, the nutrition label. This is a very important component of any product label, and you'll often see it on the back or on the side panels. As per the Nutrition Labeling and Education Act, this is a required component of most products, but again, remember the exceptions that I mentioned in the beginning. The nutrition facts must display a key set of nutrients, and we will absolutely get to that in a moment, but let's talk about the other things. The nutrition facts have to refer to a specific serving size. That serving size should refer to the amount of that product that a person is expected to consume in one sitting, and it should use straightforward, easy to understand household measurements. This will mean that for, say, a product where it's a single serving size per container, the nutrition facts have to apply to the entire contents of that container. So if you have a cup of yogurt that's meant to be eaten by one person in one sitting, then that serving size must apply to the entire container. For a bag of snacks where it's all in pieces, like potato chips, you would usually list the number of pieces they're expected to eat in one sitting. For a single serving bag, it would be the whole bag, but for a bigger, like family size one, you want to list the number of chips that they typically eat in one sitting. For some products like ice cream, they're served in pints, and then the person's expected to take a certain amount of it at a time, not the whole container. The most common measurement for that would be like 2/3 of a cup. For sauces, you may want to measure that in teaspoons or tablespoons, depending on what makes more sense for that particular item. So on and so forth. If you know for a fact that your product is either consumed partially or completely, so going back to the ice cream example, the pint is meant to be eaten in 3 sittings, but there are people who eat the entire container in one sitting. You would have something called dual column labeling, where you have 2 sets of nutrition facts. On one side, it would be the nutrition facts for the 2/3 of a cup, and then on the other side, it would be for the entire pint. So that is what you must reference in terms of the size when you report the nutrition facts on a product label. Now, in addition to reporting the serving size that your label is referring to, you must also communicate to the consumer how much of a particular nutrient that your product provides in that serving size. You do need to list the absolute amounts in numbers, but another important way to report it is in terms of percent daily value. Now, a lot of the daily values that you see on nutrition labels are based on something called reference dietary intakes, or rather reference daily intakes, or RDIs. Those RDIs are values for certain nutrients, or the amounts, found through research that have been determined to meet the needs of 98% of the healthy population. Now, those RDIs, as well as the nutrients that must be listed, have changed since 2016, based on the review of more recent scientific literature. And I used to teach the differences between the post-2016 label and the pre-2016 label, but by now the vast majority of labels out there should have met the current standards already. Just focus on the current nutrition labeling requirements. Now, as far as what nutrients has to be listed on the current label and what their daily values are, here's the list. I'm not going to go into a whole lot of detail here, just use this list when dealing with any sort of calculations. Speaking of nutritional calculations, here's how it's usually done. Some larger companies have their own in-house nutritional labs, but this is often done with a third-party lab. These labs have all sorts of methods for dealing with the nutritional analysis. They will always specify what they are, and they usually stick to standardized methods. That usually depends on what type of industry they're in. Now, regardless of what methods are used, they will usually compile a list of those results, and those results are reported on a document called a Certificate of Analysis, or COA. The COA is actually designed for all sorts of specifications, You have to compare everything on there to make sure it meets the specifications of your company. But the COA is very useful for using as a reference guide for nutrition calculations. If you have the slides downloaded, you can click on that link there to see an example. Now, COAs often are reported in terms of 100 grams or 100 mils. For laboratory convenience, it just makes the most sense to use that as a reference size. But it's rather rare for the serving size to actually be 100 grams or 100 mils. And so you have to make a conversion. The easiest way to make that conversion is through a technique in math called proportions. Basically, what happens is, let's say you have a ratio. So in this case, a certain amount of fat per 100 grams of sample that you have. Now, if you wanted to know how much fat was in, say, instead of 100 grams, you want to know how much fat was in 300 grams of that sample. Well, 300 grams is 3 times as big as 100 grams, right? So that must mean there is 3 times as much fat in there. But that ratio of fat to the amount of serving stayed the same. It's still X grams per 100 grams of serving. Let me see if I can visualize it. I apologize in advance. I know it's kind of awkward with paint, but let's try to make this work. Let's say I have 10 grams of fat for 100 grams of product, and I want to know how much fat is in 300 grams of that product. Well, I'm going to start by cross multiplying, so that's why I'm drawing these arrows right here. And so the left side will become 10 times 300. Let me type that out here. Okay. And this other side here, I'm going to cross multiply, is going to be 100 times x. And the beauty of cross multiplication is that for two ratios that you know are equal, if you cross multiply them, that will be equal as well. So let's just do that right there. Put the equal sign there. Now, the key to solving any equation with a variable in it is to try to move everything on one side and keep that variable isolated. So let's do that right now. There's 100 on this side, so I'm going to first try to divide both sides by 100. So 100 divided by 100 is 1, so we can cross that out. And then 10 times 300, we divide that by 100. Okay, so after this is what you should end up with. 10 times 300 divided by 100 is equal to x. And then the grams products, those eliminate each other. So for both numbers and units, if they're identical on the numerator and denominator, so the top and the bottom of the fraction, you can cross those out. That's what I'm doing there. And then we have 10 times 300 divided by 100, so let's type that out there. I'm going to group these in parentheses just to make it a little easier to see. Just stretch this out real quick so you can, it fits in the same line. And yeah, so that should be equal to 30 grams of fat. So in conclusion, if you know there's 10 grams of fat per 100 grams of that product, and you want to know how much there is in 300 grams, well, that answer is 30 grams. Now, calorie calculation is pretty simple. It's just adding up the calorie contributions offered by each nutrient that's in the food. And nutrients contribute a certain number of calories per gram. Carbohydrates provide 4 calories per gram, but that's only for things like sugar, starch, and things like sucrose, lactose, galactose. Fiber and other similar carbohydrates that are indigestible, those provide nothing. Not in terms of calories anyway, although they do have to be added to the total number of carbohydrates per serving. Proteins contribute 4 calories per gram, fat contributes 9, and alcohol contributes 7. Alcohol is often reported in terms of percent volume, so you can often estimate the percent volume that way. Alternately, you can use 5.5 calories per mil. Now, if you were to do calorie calculations yourself on a label of a product you have at home, you may notice that the calories don't match up exactly. That's because a lot of nutrients reported on nutrition facts are rounded. The rounding rules are often different based on the amount of that nutrient in there. And the level of precision that's needed is usually lower when there's more of that nutrient in there, as you can see with this list. Now, I don't expect you to memorize these, but I would know them for the test, at least know what to do with them. So I'll keep this slide in mind when taking the quizzes or the midterm. Now, you often have to compare two different products or two different formulations where there may be a certain change. and you have to calculate the percentage change in that formulation. This percent change, you've probably seen this in chemistry before. If you have two different numbers and you want to calculate the percent difference between them, you take the new value, or the second one, subtract the first one from it, divided by the first one, times 100%. If you end up with a positive result, then there's a positive percent change, and so you have more of something, or something increased. And if it's negative, it's the opposite. You have less of something, or something decreased. Okay, so I realized there's something pretty awkward about the way I'm recording how to do math problems on here. So I think I'll make a separate slide or separate handout showing how to solve these problems. But just know that there's a typo in here. 80 proof is actually 40% alcohol by volume. Same with this one. I'll attach this problem solution to the first one, and I'll post that tonight. But that link should work if you click on it. You should be able to see the nutrition data that you need for this problem. Now here's a host of different recommended readings you can use for more help on nutrition review, as well as more stuff on food labeling. There's actually a practice sheet with much simpler problems that can help you get into the mindset of what kind of problems I would put on quizzes. The most useful of these would probably be the link to the nutrition label maker, which you can use for your project. There's even a big nutrition database that the USDA keeps, and I'll link you to that if you're playing around with Excel or something at home. Something that's actually fun to play around with if you're teaching yourself data processing. So if you look in week 4 or week 3 before I finish editing this video, you'll see two different handouts. The first handout is an additional instructional handout just for further review of nutrition calculations. And then the second handout is the actual assignment. I want you to complete the problems in the second handout and then submit that on Canvas. And that's pretty much it. Leave questions and comments in the comment section below or reach out to me through email, and I'll see you next week.